like at Unitec here, where we draw in metres because they're big sites. Could be a 50 lot development or a 3 kilometre road or something. They're very big sites, so we draw in metres. But when we start drawing things like retaining walls and that sort of thing, we start drawing up and anything structural is drawn in millimetres. Now that also works really well for our lovely friends, the architects, who I say that with a wee bit of a smile on my face, because engineers have always clashed with architects. Mostly because architects make things look pretty and engineers make things stand up and not fall over. And when the two clash is where they want something to look pretty and don't care if it falls over, and suddenly there's a bit of an issue. Where also it happens is in a program called Revit, which both architects and engineers use. And there's an old adage, never leave an architect any room or they'll fill it up with something, and that's exactly what happens. So an engineer might leave a blank on Revit because they're not quite sure of a beam size, and an architect will come along and go, oh, there's a blank bit there. I'll put some air conditioning hoses and some of this and some of that there, and next thing you know, they haven't got room for a beam to hold the building up. So that sort of thing happens all the time. And some of the conversations that I've been privy to have been quite what's the word?
Robust.
What's that?
Robust.
Robust, yeah. And also depending on nationality they are, because some can go right off their rocker just at a twitch. So we're going to move into the land of structural drawing. As a rule in New Zealand, it's mostly buildings, but there are a few things like, I think Ingrid probably got you to draw some sort of retaining wall with geotextile and a bit of reinforcing and a bit of this and a bit of that as an introduction. Quite a simple little copy drawing, but if you go back to that, we're going to expand on that. And when you do your structures course with Wei or Lou or Lucia, they will teach you how to design concrete, how to work out how many rebars are in there, what size they are, what their spacings are. That's all done in structurals. A course called Structures, and they do Structures 1 and 2, and I think 3 here. What I'm doing is teaching you how to draw it, but there's some complicated maths behind how many rebars will actually be and what they look like. So a structural engineer from Auckland University will rock up and go D16s at 300 centres and walk away. A technician will have to work out what bars look like, what length they are, where the bend is, how much they take off for the bend, what the overall length is, and eventually how much in weight the reinforcing is. And that's what I'm going to make you do, okay? So you're not going to sit there and do some calcs on how many rebars, what spacings and all the rest there are in terms of a structural design, but you're going to take the structural design and make a technical drawing out of it. So, without further ado, I've made week 9 notes available. I'll come back to them. You'll also notice that week 9, 10, 11, 12, it's very much like the civil notes. I'll release them as each week comes along. Because you're degree students, you've also got a few extra things on the go, and I'll talk about that in a second. If you look on Moodle, you'll see the group that you've been put into for your presentation. There'll be 2 groups, and you'll have to work quietly towards that. That'll be in the week of the 28th, which is still a month away at least, 5 weeks, but it'll creep up real quick. Don't worry about that with all your other things you've got on. So I would suggest to get into your groups in the holidays, or not holidays, the break. Come in and, you know, a room like this might be open and sit down. The teacher's desks are the same as these desks. So when you log in just with your student ID, and there's a button here that says PC. If you hit the PC button, everything happens. That comes down, and whatever's on your screen is shown over there. All right. So you can practice that. You can talk about who's going to do what, whether you're going to break the PowerPoint into 2 or 3 sections, who's going to be the person going click, click, click and hiding behind the monitor, who's going to be the person that does the presentations. Yeah, I know. We used to do a work function every year. It was a consultancy engineering one, and they picked on a couple of volunteers to dress up and do a thing on the stage. And the people that picked us, one of them was a girl, and she was the most shyest girl ever. And not only did she only want to click the buttons, but she put pot plants all around her so no one could actually see her at all. So we were the clowns getting laughed at, and she was the one putting all the stuff on the overhead projectors. But anyway, yeah, everyone has to have a go if you want to pass this course. So just to reiterate that, you can't pass this course by getting out of the presentation. All right. Everything in the degree must be attempted to pass a course. It's part of the rule. Not my rules, it's the degree rules. So basically by pulling out of that, you're pulling out of the course really. Now unfortunately, you've all seen the spread of marks, and there are some students there that are teetering on possibly pulling out already, and those students may pick up and start getting better, but they may also start tapering off. Now, just a heads up, there's about 11 or 12 in each group. I'm expecting it to finish on about 9 or 8. So be prepared for Johnny Smith, right, or Mr. Kim or Mr. Muhammad or whoever to suddenly at the last minute go, oh, I'm not presenting now, I've got a cold or whatever, okay? Now that's fine, but someone in the group has to cover what they were going to do. And there is a small catch to the presentation that you will get when you do your final research subject, is I will every now and then stop someone and ask about what they're talking about. So if they've had it written for them, and say it's environmental, and they're going blah 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 Pukeko, blah 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 wetlands, blah blah blah, and I'll go, excuse me, yeah. So what do you mean by protecting the job from the Pukeko? And they'll just go, I don't know what you're talking about because someone else has written this book, right? So you're going to, every now and then I'm going to do that. So be prepared if you don't know what you're talking about for the odd question.
How often is every now and then, Roger?
Well, you know, I might miss everyone out and then just, you know, ask you, for example.
Right. Okay.
Whoever's sort of asked the most questions in class gets them back at them.
Okay.
Everyone's got quiet. Yeah, no, it's the other thing is that everybody gets a group mark, and the group mark is based on your overall presentation, and the marks individually are average. Okay, so the reason why I divided you into groups rather than let you go into groups was I went with the top student down to the bottom one, 1, 2, 1, 2, 1, 2, 1, 2. You don't know who the bottom one is or the top one is. That way there was a fair mix of people, right? So there will be, some that are weak and some that are really good. You may decide to let the good person do 2 presentations and the weaker person just do 1. But that might increase your chance of being the better group. Now, what I don't know if I said or not, but there's an extra half a mark for the top, just to dangle it out there, there's an extra half a mark for the group that has the highest average, okay? And I'll let you know that on the day. I won't let you know your individual marks, until I can put an ID beside them. It's not fair, but I can tell you your average for the group. So you'll get a mark out of 5 for yourself, you'll get a mark out of 5 for your group. The combined mark will be yours, and if you're lucky enough to be the best group, you'll get an extra half a mark. Now, generally the average is around 8, sometimes higher out of 10. So it's a great chance to catch up some marks if some of your drawings have been a bit weak, all right? The other thing is that each year up until recently I was offering not to do the design report and the presentation to a repeat student, but I'm not allowed to do that with the design report, but I can allow them to carry over their presentation mark. I don't see why they should have to do that 2 years in a row. So you will see 2 or 3 students in the classes, 3 I think, that won't be there, and you'll see a strange number beside them for their presentation, wondering what group they were in. It's a carryover mark, alright? So that's the presentation. The groups are there. I've called you something like green and blue. I suggest you change the name to some sort of construction name and come in from the angle of a construction company trying to beat the work. Alright? So each member of your team is quite vital because they're going to talk about what they're going to be doing with respect to each small part of the job. Obviously, you've still got your design report to go. Now, the rules with the presentation is you can use anybody's design reports in your presentation, but they must be in your group. So you can't use someone from another group. Why would you anyway? I mean, why would they give it to you? You can use anyone from in your group's drawings. You can use anyone's notes and stuff from their drawings in your group. So if you get together with what you got and someone can go, well, look, I know a lot about the local iwi here. It's my grandfather, blah, blah, blah. Fine, let them write that up. Another person might go, hey, I've been getting A's for my drawings. Okay, we'll use your drawings, all right? On that topic, in a minute I'm going to show you the assignment. Now, last week I sketched something on the board, roughly what it was going to be, which is quite common. You do a design report and all you get is a bit of a funny whiteboard sketch, right? But sometimes the client says, well, actually, this is what I want, and that's what I'm about to do to you. So you need to copy paste my sketches into your report and update it. If that sketch was rubbish, then update it to what my, if you've talked about the beams being 312s by such and such, and it turns out that mine, they're 320 beams, you're going to have to change that on your text, if you've advanced it that far. It isn't a big deal, the design report, it is only sort of 1,000 to 1,500 words. And most of you that have done reports will find that you'll eat that up real quick. You could probably chew it up in the morning easily enough. So, yeah, the main thing is if you have made a start, have a look at the assignment and see what you'd like to take. There's also a 3D sketch, you're welcome to put that in there. Not necessary, but welcome. It's quite good because you can actually show that and point to things on the 3D to do with the job. And you can see how big the beams are, and you're gonna need some pretty big trucks to bring them onto the site. So there's a few extra issues that might raise their head today, just make you aware of that. So the concrete notes I'm going to go over after I've introduced you to the assignment. So let's become familiar with that first up, and what I'm about to tell you is very important in terms of trying to get you to get some good marks for the assignment. So it's made available under assessments. Just be careful you don't put your client proposal into the assignment Dropbox and vice versa. It might seem funny, but you will lose a half a mark for doing that, because I won't be able to find it, and I'll start marking, and then I'll go to mark the design report or other way around, and I'll find something in the wrong box. It does end up with quite a bit of extra time for me, so I tend to have positive time for me equals negative marks for students. Okay, well, you can open up the assignment if you want to. I think the first thing that I did with the diplomas was I opened up the 3D sketch. And that's it, that's your structural assignment, and as you can see, this year, unfortunately, for you, you've picked the year of the trust, all right? I know with the Chinese calendar, they have the year of the tiger and the year of the eagle and the year of the rabbit. This is the year of the trust. Last time, they just had a simple purlin. See those things on top of the roof, the reds?
This is the tractor shed, isn't it?
This is a tractor shed.
Okay.
This is the most over-designed tractor shed you're ever going to see. It's also in the most unpractical part of Unitec, down the side of a hill. But if I don't do that and I put it on the flat and I make it look like an ordinary building, you'll all fall asleep.
Oh,
You've got to learn how to do these things, or you'll go to work and your first job will have a truss on it and you'll run a mile, okay? The good thing is, I'll give you the bad news and the good news. The bad news is you've got the truss. Last year, there was only a purlin on the roof, these things here. A flat roof with a purlin on it, all right? All you had as far as timber went was 6 pieces of timber. Done. This year you've got quite a lot of timber. Last year they had quite a few beams and columns. This year you've got 1, 2, 3, 4 columns and 1, 2 beams. So less steel, which means less bolts, which means less welding, which means less plates on the top. These are little plates here. Okay, so there's swings and roundabouts. When you're doing your 3D, the first thing you look at is, oh, that is going to take me at least a month to draw in 3D. Well, in actual fact, with 3D, we draw up the truss, one of them, and then we just go copy, 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 copy. And then we put one of these on and go copy, 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 copy. And the good news is I will draw all of this up for you and that camera, and you can go back and try and do it yourself, all right? Bad news is that's only 60% of the 3D, and you'll have to, for the other 40%, the golden marks, you'll have to start putting nuts and bolts and welds, and there's going to be a pipe go around the outside edge, and there'll be some hard fill underneath. So I push you so far, and I leave you to try and do the rest, all right? Of course, that has to end up in a viewport. You can twist it around. Remember with Ingrid on the first day, you played with a 3D block or something, and it's the same principle for moving around. You can do that in the viewport. The weird thing is that you can actually render in the viewport, but in model space it's just lines. And in model space, it might be a plan view. In the viewport, you've got this 3D rendered image, which is really quite weird, okay? But I can explain all that as well. The 3D is actually good fun, in my opinion. I know that most of my life I've been drawing, so, you know, I get excited about things that make you guys fall off to sleep. But it can be quite fun, compared with swatting for, say, structures, okay? Or fluids. Much will get on there and start playing with the 3D, because you can see something being built while you're doing
Well,
it, right?
some of the drawings now, the digital drawings, they include 3D rendered models,
Yes.
and you can actually pull it apart, isolate levels, column bases.
So AutoCAD is a program where we tend to make things look a bit prettier, make them look good, more professional. We bring in photographs, we bring in aerial photographs, we bring in GIS data. Everything can come into AutoCAD. But the main program for doing 3D is Revit, which you guys will learn on your last year here at Unitec. Because that's basically 4D. And what that means is, on top of the fact you can produce a model, every time you extrude a beam, or change a beam, or chop a beam off, put a column in, over here is a big, kind of like a spreadsheet, which gives you an output of exactly what's in the building. So if you ever thought of becoming a QS, don't. That job will go very soon completely to computers.
To deal with people though.
Yeah, but remember, that's only a spreadsheet of what's there. You still got to put it in another one to do the pricing. Yeah. So just to give you an idea how much fun it is, I had a Russian student about 4 years ago decided to download is it called a MintJet? MintJet, I think it's called a MintJet, yeah. And put it inside the building as a little surprise for me when I opened up his 3D sketch. And it was something like a tractor shed or a storage shed.
With a jet.
With a jet inside it, right?
Well, that's suitable.
I also had an Indian student who decided we did a bridge. He thought it very funny to put a whole lot of monkeys on the bridge. Hanging. They were 3D monkeys in AutoCAD. I don't know where he got it from. Might have drawn them up himself. So I got a good laugh out of that, and then I took some marks off both of them because it wasn't what I asked for, right? They're just being smart because they could. So you can just about download anything on AutoCAD on the internet. A word of warning, nuts, bolts, screws and that, they're all on the internet. If you download them, they're fairly big files because they've drawn them very, very precisely, and I don't require that. You know how a washer's got a slight bevel on it? They're very precise. So you put, I don't know, on that, looking at the thing up the top there, with wooden structures you use washers, as well as screws and nuts and bolts. You might have as many as 200 on there. You copy that 200 times around that drawing, suddenly it goes from, 10 meg to 200 meg, and you can't get it on Moodle. And I get an email from my good student saying, I went to upload on the last day and it doesn't work. So out comes my violin, because I'm not going to come into Unitec on the 3rd of November to meet you so you can give me your memory stick. So there's a limit of 50 meg. So just be careful of that. I know you'll forget it, but just try and remember that in your memory bank when you're doing it. So we will have a week where I'll go over that 3D side of things.
Roger, is this for one tractor or two tractors?
To what?
Is this for one tractor or two tractors?
You'll see that in a second. Good
If
question.
it's for one tractor, do we have to consider there's probably going to be more pressure on that side? In other words, not a symmetric sort of.
Oh, in terms of pressures, no. You see, not only students can do it, but I can do it too.
Oh, sweet.
Okay.
Cool.
I'm only being smart. I don't get many chances to do this. You've got to take things with a grain of salt sometimes.
Yeah.
I even downloaded the side one. You don't have to draw the tractors. You don't have to draw the, whatever the hell that other thing is there, some sort of cleaner. just be aware that if they did do a tractor shed here, it would be somewhere where they stored all their rubbish as well, of all the gardening stuff, and maintenance for around the buildings. There'd probably be a bench, there'd probably be electrical lighting, and you know, probably they'd have their cups of tea over there as well. The workers, they wouldn't come into the hub and have a flash coffee, they'd be making cups of teas and having their lunch there. So all of those services will have to be brought into the building. Apart, you don't, as structural people, you don't need to worry about services so much, but if you're doing a design report on it, you need to at least have somebody say, you know, we might need to bring some sewage and some electrical lighting outside and lighting inside and some power points and hold on, maybe we should bring some comms in there too, because they'll probably want the internet in there as well. Maybe that thing there's one of those automatic lawnmowers that works off the internet, who knows? And so the answer to your question is pretty much on that sketch one. Half of it'll be for that, half it'll be for else. And that is a super over-designed slab. You would never put that much reinforcing in a fairly simple building or a garage. Yes, you'll put mesh, and yes, you'll put it in the foundations, but it's fairly rare to have it in two layers of D16s in a ordinary slab here.
Are we doing a bridging slab or just an ordinary?
In terms, that is basically is a bridging slab,
Yeah.
you know, and that probably takes care of that issue with the pipe being fairly close
Just the
underneath.
meter or whatever, close to it?
Yeah, yeah. The other thing is, if you see there, I've got a bit lazy, I've only drawn up half of the truss, but there's a command on AutoCAD called mirror, so you may only have to draw half of it yourself, alright? Mirror, one side to the other, Michael Jackson. Is it okay to talk about him now? Probably not. Yeah, so going back to sketch 2, I got really lazy here. Hold on. So you can almost copy my first sketch, because that's what you're going to have to draw up for 3 or 4 marks. Can't remember how many. For this one, you're going to have to work out what it actually looks like from the sideways view, from that view there, looking that way. So I've drawn up that view, or half of it. You're going to have to kind of work out what it looks like from that side. So that's testing those skills that Ingrid taught you on, you know, one side looking that way, or a sectional view. Let's have a look at the assignment. A lot of you are sort of looking at me wondering what I'm talking about. The assignment is also available there. You can bring it up on your own screens. And it outlines the hand-in. So I've provided, that's the 2 sketches I showed you, and I've also provided a drawing called steel members. So don't go drawing up the steel members just yet, because I've actually provided that, and we'll use that for our 3D, and you can use that for your elevational views as well. I've also provided a template which you're going to have to do schedules of quantities on. Now, if you have a look at the template, it's kind of divided into regions. This is only an example, okay? The first thing, you can't read this, but the first thing student is written here is path. The first thing students do is they email me, oh Roger, there's no path. Right? I know there's no path, but this is an example of a schedule of quantities, okay? So the concrete part is here, So that's going to include the concrete, the hard fill, the filter material, pipe, no path, and the actual concrete itself, the volume. Now, most of you will be well within your capabilities of working out those. Yep.
Plant and labour as well in this section?
No labour in that, although that can be part of what you would do as an engineer, but not for me. The steel, there's 4 members, and we schedule it like that. I'm going to zoom in on some of these in a minute and show you what the text is, but you could be able to do it yourself. The hardware, the truss, plus the things that are holding it together, the screws, the nuts, the bolts. We'll have a session on that straight after the holidays. The bar schedule is worth 5 marks. So this is worth 5 marks. Because you're the year of the truss, most of the marks are going to be in that. Last time, there was only 6 bits of timber, so most of the marks were in this part. All right, so they swap around. I'll zoom in on those and you might be able to see them a bit clearer. So the quantities there, you can see that you've got your concrete, your foundation, your filter, and I've put here as a guide cross-sectional area and length. Well, you don't actually have to do that. You can just put cross-sectional area and total volume. It's up to you how you do your totals there. When I mark it, I'm only looking at these right-hand side marks. With the pipe, it will be length, because there'll be an overall length of the pipe. With the beams, next week we're going to do something quite interesting. We're going to schedule some, I'm not sure what you can see there, you can see it. We're going to schedule some steel next week, and we're going to do it with something called a girder, which is something that you would find in a garage. You know when you drive your car into the garage and they say, sorry ma'am or sorry sir, but you're going to have to take the engine out, and there's those big chain things that they do this and they pull the engine up. If you've ever watched any of the Fast and Furious, they spend most of the time doing that. Okay, those chains are on a hook type thing, a crane type thing, and normally they slide along a beam, and it's in the middle of the garage, and that beam is very strong to take the weight of an engine, which would be at least 1 ton, maybe 2. So we're going to be doing a girder, is what that's called, which is a strengthened beam, and that girder is going to be in your test in the last week or so of the course. So what we do in the girder will be reflected in the test, and also you'll use your learning outcomes to do this, and that's all next week. So everything sort of aims back at the project and also the test. So after next week you should be able to do your steel, you should be able to do the concrete this week. In fact, you could do that right now. If you had a look at the 3D sketch of the concrete, it's pretty obvious that it's in an upside down U shape. You forget about the reinforcing, you just do the actual quantity of that. So there's 2 ways to do it. You could divide it into 3, so the footings on each side and the slab, or you could do a cross-sectional area and multiply it by the length. Either or should get the same answer. The steel work, as I said, you should be able to do that as well. And the reinforcing is what we're going to be going over today. That's what you've got to stay awake for, because this table here, once you can do that table, you can relate it to the plan that you have to draw. Okay? let's go back to the assignment. You're required to do the following. A, draw a plan of the foundation slab. Now, the plan view of reinforcing concrete. This is how we show reinforcing concrete. And so the first thing we do is we show the outline of the concrete, and then we show like the bar, and the bar's got a thickness. Remember with Ingrid you drew, I think it was D16s, they were P-lines, and you made them thicker, right?
P-edit?
It's yeah, P-edit, exactly. And so you show one bar. Now that bar, there might be 20 of those going all the way down here. But we don't show all 20. We show one bar, and we put one here, and one small one here. So what that's saying, and we haven't quite finished it yet, we put an ordinary dimension line down here with an arrow and a circle twice the size of the bar. And what that's telling me is that that bar goes from there to there, but we don't know how many of them there are. And later on in the notes, I'll show you what we put on top of the bar. There's a special code we put on there which tells you what centers it is, what bar mark it is, what diameter it is, and how many of them there are. And you need to do that for all 5 bars that are on your assignment, okay? So in order to help you do that, you also have to do a bar schedule. So one thing's drawing it, the other thing's doing a schedule. And if you have a look back at the schedule example, somewhere,
Left.
we'll get there.
Yeah.
There. With the schedule, there is each one of these bars has got a location, a bar mark, the number of them, the length of them, how much mass is. Now that mass is depending on the thickness of the bar. Obviously a really thin bar would be not as heavy as a really fat one, right? So that's your mass. So that times that times that times that equals a total. We total them all up down the bottom and we get a total amount for your bars, all right? Reinforcing is a strange thing. If you go to some of your third world countries around the world, or third world areas of countries, reinforcing bars can be worth a week's wages. If you look at a week's wages for a labourer in New Zealand, I don't know, maybe $1,000 a week. So they can be as much as one bar is the same as $1,000.
It always gets stolen on the side if you put there.
Exactly. It's exactly
It
what I'm
happens
about
every
to
day.
say. It depends on what country you're in, all right? In New Zealand, it's not worth it. It might be worth $20, $30, something like that. You don't want to lose your job because somebody's caught you putting it in the back of your car. All right, even if you put 4 in the back of the car, you don't really want to lose your job for that. But overseas, if you got 4 in the back of the car and it's the equivalent of $4,000, of course they're going to be doing that all the time. And that's why you see earthquakes in these places and buildings falling down and everyone's going like, what did that happen? Oh, there's no reinforcing in them. What they actually do is they pay, in some countries, they pay the council guy comes out to check, and somebody's putting some money in his back pocket and he goes, okay, I see nothing, and he walks off and signs the papers, as he's going that way, the concrete truck's coming this way, and the boys are taking the reinforcing out before they put the concrete in. And who's going to know until there's an earthquake, right? In New Zealand, we over-design because we have a lot of earthquakes. But I think there's a certain point with concrete where it's going to fall anyway, and that's probably around about an 8 or something like that. And that's when you probably need to be designing buildings out of timber or something a bit more flexible. Just a couple of quick stories. I used to work for Foodstuffs some time back, and they had a massive earthquake in a place called Edgecombe down by Wakatani in east of the North Island. It was a 6.8, and it was epicentered in Edgecombe. And the Edgecombe New World guy came to work in Auckland here, and he was full of stories. For a start, he actually delivered a baby in the car park after the earthquake hit. Secondly, his best friend was up the top of what they called Mount Edgecombe, just further on. There's a mountain there by Kaurau called Mount Edgecombe. And he was actually up the top doing something, and he saw the earthquake coming, and he said the whole ground folded like this, coming towards him like a big wave. And then there's two of them up there, and they're like, oh no, we're seeing things. And then all of a sudden, you know, they were shook. The railway line got realigned by about 20 metres from one side to the other, where it was lifted and placed over there. But in the New World itself, the concrete columns, like this column in the middle of the room, it was going up and down so hard, the bottom 2 foot of the column turned into just steel. It was all that was left. All the rest was powder. And the shelves were completely, you know, there was nothing left on the shelves, and people just got out in time. So we design in New Zealand to get people out of there. But in terms of how we design, it's usually over-designed compared with a lot of other countries. So when engineers from England and that come here and expect to walk into an office, they aren't given straight away registration. They have to sit special papers for New Zealand to make sure they're up to our codes of practice. Because in England, let's face it, they don't have many earthquakes at all. So they don't, you know, they don't have to do fancy design. So when we go over calculating bars and things, I'll take that 20% into my calculations, and I'll show you exactly what I'm talking about. Okay. I've worked in structural engineering offices in England for a company that mostly did drawings in Saudi Arabia and Libya, and we had to calculate the bars for bar shields like that. I was pretty much doing one of those every other hour that I was working there. And on the Clyde Dam in New Zealand, when I did it, I was working for Germans, and they were so precise that if we didn't get it within 10 millimetres and the bar came down and the cages came down and didn't fit, the cage had to go back and get modified, and all that was lost time. And anything over 5 minutes, and we absolutely got pounded by the German hierarchy, hauled into the office and told off and all the rest, because that was 5 minutes worth of concrete pouring they couldn't do, which was around about 4 or 5 or 6 truckloads they couldn't put down the hole, which meant they were losing money. And everything with Germany, like their train system, is timed down to the last second. So we had already lost them 5 minutes of money. So yeah, that was quite high pressure stuff, and you didn't want to make, imagine the cages coming down and just one corner was calculated wrong and it touched and it wouldn't go over the top. So yeah, we had to check and double check beforehand. So I've had a bit of experience with this, and the construction companies in New Zealand will make you do this. The consultancies won't. They will make you just do drawings with these, like what Ingrid did like D16s at 300 centres and point to the bar. I won't tell you how many, because they're doing it for a different purpose. They do it so that the construction companies can put a bid in for the work. So they tell them what's in there, but they don't want to know how they do the calcs. So you may work for one, or you may work for the other, or you could be the person on site with the most important job, which is counting the reinforcing bars. Now, in New Zealand, they don't tend to try to do Swifties on you, so you'll probably find it's not too bad. But they do have a guy that is normally in charge of the steelies. He's normally about 4 times wider than me, with tattoos all on him, and about half my height. And he looks at you like this as you're counting the bars. 1, 2, you got your clipboard. 1, 2, 3, 4, 5, right? And so quite intimidating, and all his guys are behind him waiting to carry on. But you've got the most important job. You might be the junior in the office being sent out to count them. But if they're short, you've got to tell them, hey, you need another row of bars. That's not in the design. It's going to fall down. And if you do catch them out, they get very grumpy about it, but they will do it. The other thing is they have to be evenly spaced, and they get a bit lazy, and they tend to be, and whoop, whoop, you know, they're supposed to be evenly spaced so the whole structure is evenly supported. And you find that out on site pretty quickly when you start to become the person that does the counting, but it's really important. Imagine being the person that counted the rebars in the CCTV building in Christchurch, you know. When they found out it had collapsed, you would be feeling really horrible. So, yeah, it's a job on site that means you have to have an idea of what the bar schedule looks like, what the bars look like, because you've only got one chance to see them all, and then they put concrete in. All right? So when you go away from today's lecture, you can do the reinforcing schedule for 5 marks, you can do the plan, and by the way, that's only one bar. If you've got another bar, it might go from here, and it might overlap with one. And so if it's overlapping, you want to show where that goes to. Now that one might go to here, the bar there, the bar there. But this one here, that might overlap, but it might only go to that point. And then there might be another bar that goes down like that, and that goes to there. So it's important to get the right thickness on the bar that you're actually talking about, and to get the right, what we call a delimiter bar, okay? Delimiter or terminator, whatever you want to call it, it's the last bar that is there. Now that looks rather simple, but what if you've got 5 bars? It's starting to get quite messy. And if you have to write on top of the bar, the rule is you're not allowed to have anything going through it, through your writing. So it becomes a bit like that game that you play on your cell phone, Tetris, where you're moving them around so everything fits into place. So you draw it first, and then you move it so that the text doesn't clash with anything. You're very lucky doing it on CAD. I had to do it manually by drawing board. So you draw it all up, and then it's clashing. So you've got to get your rubber out. In my case, we had ink, so it was an electric rubber. Then you had to buff it, and then you redid it. Still doesn't work. And then so many, and it's like the dentist. You just go straight through the material, and you have to start again. So we're very frustrating in those days. You simply go bang, move.
Control Z.
Control Z, or undo. Yeah, I didn't have an undo button. I remember in 1982, where this guy came in as salesman, he said, it's the next best thing to drafting. And we what? And he puts this thing on our boards. Say this is the board. You put it on, and connected it to the horizontal piece on the drawing board, and he said, watch this, and he goes, and it went, and it wrote, you know, Roger Gibb or something there, and I'm like, wow, you know, and it wrote it on the drawing, and I said, wow, that's the way of the future, you know. Those machines lasted about 2 years, and then AutoCAD came in. But so we had images of setting that up all around our drawing and not having to do any more work. Oh, sorry, it's an old person story, but it's quite an interesting one. So you'll be able to do the reinforcing, you'll be able to do after next week the steel. The truss I'd wait till after the holidays, and the materials you should ace that as well. So there's quite a lot of this you can do. After the holidays we'll do our 3D, and there'll be a little bit of time at each lecture after the holidays to get your groups together. Today, I suggest after the class that you say, you know, my name's John Smith and I'm an alcoholic. No, don't say that. My name's John Smith and I'm in Group A. Oh, who else is in Group A? Just sort of get together, swap cell phones, whatever you want to do, or create a WhatsApp group or whatever. I didn't want to do that. I think your personal emails I shouldn't be sharing, but you can do what you like in your group, all right? Okay, so I'm going to now go to the notes and very quickly go through them, and then I'm going to do an example. We'll have a wee break of about 5 minutes. The example is extremely important because that'll help you do your schedule, reinforcing schedule. With this drawing assignment 3, can you all please go file new ACAD like you did with Ingrid and start a brand new drawing. So I don't want to see a start time on the drawing of 1995 or something, and I don't want to see the same start time as the civil drawing that I gave you as well. With this, it's a brand new fresh drawing. I'd like you to do it as a fresh drawing, so it must start after today's date because you didn't know what the assignment was before today's date. Otherwise it's sort of saying to me, oh, my mate did this that was here 2 years ago, and I've just modified their drawing. This is an old assignment, but I always change things a wee bit, and I usually do things that students wouldn't immediately see. So be careful. If you have got access to it, it won't be 100% the same, and I'll know if you've done the one in 2021, I think. Okay, so let's have a look back at the notes. Week 9. Even although the general consensus about me at Unitec is that I do go blah, 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 I'm not going to go blah, blah, blah with the notes. I promise you. We're going to very quickly go through them. I'll tell you the areas where you need to have a look at more. If you want to print them and mark them out in the future, that's quite a good idea. Remember, the test will be open book. So the quicker, as you know from the last test, the quicker you can get to the section you want to look at, the easier the question can be. So let's start from the beginning, and I'll just whiz through what we need to and don't need to. So we have two types of concrete. We have plain concrete, which basically means no reinforcing. In a lot of third world countries, they use those for quite extensive retaining walls and all sorts of things. In New Zealand, we only use them for things like driveways and footpaths and things that aren't really going to end up killing people. All right, maybe small retaining walls, maybe garden edges and things like that. Then you have reinforced concrete, which is divided into two categories. What we call in situ, which I think is Latin for on site, If it's not, I'm gonna call it that, because I never did Latin. I didn't want to end up writing like my doctor, because you can't even read that, so that's why I didn't do Latin. So in situ on site, so that means we're pouring some concrete on site, and then there's precast concrete. Precast concrete is more expensive, but they tend to have reinforcing where they stretch it and then they pour the concrete around it, and then that concrete sets. And the precast concrete, they can do things like beams across motorways, and the good thing about that, they pick them up on a truck and put them there overnight, so you don't see it. You go to work under a bridge, and they're doing a bridge, and there's no bridge there one day, and you go the next day to work, and there's a bridge going across there, because they can get a couple of beams in a night put into position. They just close the motorway off at midnight or something. Whereas if you were to do in situ concrete, they'd have to box it all up, get it all ready, get the reinforcing in place, and probably close the motorway for half a year just to get the bridge in. I watched the bridge being made up in north of Auckland, going towards Warkworth, and that was a long process, and they could never have done that while the motorway was open. So in situ, they also use it for other reasons. Things like precast panels. You would notice maybe going into town one day, nothing. Next day, 3 or 4 days later, you go and there's a 4-story car park there, already getting ready. How did that happen so quickly? Well, they brought in the precast panels, either vertical or horizontal, and they've stacked them up pretty quickly. So precast has its place. It's quite strong. It's already strong when it comes on site. But also in situ has its place as well, especially with difficult areas, etc. One thing that is in the test that students often get wrong. If I was to do this here and put a couple of what we call formwork here, and then we put our concrete in. We all know that concrete's little triangles and dots. And something's got to hold that up, so we've got a peg in the ground and a bit of wood on an angle. That there is called formwork. And I guess that's logical, taken from the word form. It's forming the concrete. F-O-R-M, form. That there is called false work. I don't know why they call it false work, but it is what holds the formwork up while the concrete's setting. That is what we in New Zealand call boxing. So when you hear about someone saying, we're going to go and get some boxing to make some concrete, they're getting some formwork and they're getting some of these pieces here to hold it up. Obviously with a footpath or a driveway, the formwork's only that high, and it's like an edging, and this is usually just a steel pole in the ground to stop it, But when it gets to a complicated structure like, say, a retaining wall, these are things that we refer to it. Now, it gets more important because what Max said before, and he didn't realise it, is that each one of these things has a number beside it in terms of labour. So if you're going to have formwork that requires false work, the labour cost changes. So the labour becomes almost the same price as this stuff. On the Clyde Dam, they were using the cheapest possible timber, because they had a labourer going around behind once it's set, whacking all the false work off, picking it up. They had another labourer that was taking the nails out, and it was going in a big bin, and staff were pulling up one after another in their trailers after work and taking it away for firewood. I don't know if you know much about Central Otago, minus 40 in the winter and plus 40 in the summer. So anything that burnt meant that you got away with your power bills a bit, and all the site houses had fires. So they were doing two things with one stone, I suppose. They were providing false work for
And recycling.
and yeah, well, recycling as well. There we are. The environmentalists, the greenies, would have been really pleased about that. So there was a lot of people with handkerchiefs on their
Well,
heads,
they
right?
prefer you to build something but they're not burn it, you know?
Yeah. Oh, true. Yeah, burning it's only going to put more carbon into the atmosphere, so you're kind of shooting yourself in the foot. Yeah, a bit like a greenie wearing a handkerchief and sandals and that on their bike and then going off the edge of a cliff. The formwork on big jobs is sometimes steel, and they wash it down and move it along to the next part of the retaining wall, and then they use some false work to hold it up, and then they carry on. So you might get the same shutters, they call them shutters, used off if they've got a big job, say, you know, a few hundred metres, they'll do that. Interesting. I've decided to put a question on that in the test, so I thought I'd better do a wee sketch for you. Only fairness. So if you take a photo of that, you can bring it into the test with you. I'm not saying you'll get that question, but if you don't take a photo of it, don't put your hand up and ask me what formwork and false work is. And you might pay to cut that bit out about the greenies when you upload the recording, or else I'll have some of those parliamentarians on my back. Okay, there's a little sketch here saying that concrete resists compression if it's got reinforcing in it, and basically that's the reason why we put reinforcing in concrete. There's a typical cage situation. The bars holding the two major ones together are called ties, and they're normally a smaller diameter bar. So that's the sort of thing you get. This on the right hand side is what you might get faced with on site to count. And I know it's a bit boring, but the other thing you should also have is a tape measure to go along and make sure they're relatively even spaces. What always amuses me on site is that the workers think they know everything, and you turn up as an engineering technician and you're nothing, you know nothing. But the minute something goes wrong, the workers run a mile and say, oh, he's to blame or she's to blame. They're very quick to put the blame onto the person that's sitting in the site office that's in charge. But when you come out and tell them to do something, they're always, oh no, we know better. So there's a fine line there on site to keep things going along with health and safety. It's pretty much one of the biggest parts of your job. This interesting little photo, this was taken at Waterview when they were making those big tall piles over there that hold up the columns, that hold up the motorway. They had shutters there, and they moved the shutters up, and they had circular reinforcing, which they got in place, and then they kept moving the shutters up after each pour, which was quite a clever way of doing it, and it was actually taken on site. In those days we used to take students over there to have a look at it all, which was pretty cool. $4 billion job on our back doorstep. Now all we've got is noise around the place. I'll whiz past this, but a gravity dam is just basically concrete, using the weight of the concrete to stop the water from coming back. These are all examples of the use of concrete. These are examples of retaining walls being used, and what I was saying before about the precast beams. and precast panels. Twin T's, question in the test, when would you get an advantage out of using a twin T rather than a uni T or a single T?
Is that actually in the test or you?
Yeah,
Oh, cool.
well, I tell stories as well. And the story is about Mount Albert Pack and Save, which I got involved with the design. And we were doing the earthworks and suddenly came across the lava flow coming down from Mount Albert, or one of the old lava flows. And the guys on site went, oh well, we're going to need dynamite because it was so hard to move. The bucket wasn't doing anything. And so they did some calculations and went, holy hell, this is going to cost a lot more than we thought, because Mount Albert Pack and Save's got a car park underneath it. And under council rules, you've got a minimum height. And someone came up with the idea of using twin T's because they didn't go down as far. The twin T's might have been about this high, whereas the uni T's were about that high. And that extra 100 to 200 mil of height over the whole car park area underneath the Pack and Save saved us a lot of money in excavation. We're talking closing on quite a few 100,000, it was closing more like $1 million extra that we saved by using Uni-Ts. However, so the answer to that is, Uni-Ts are good when you've got a very limited height restriction in a building. However, what we didn't realise was, and no one had done the calcs, that with a Pack and Save, there's a lot of weight up there, way above, you know, with all the things stacked up. So the original design had to be designed like that. The floor was curved. So originally it's curved, and as it got weight on it, became more horizontal, right? So the Uni-Ts were set in place, very slight curve on them.
Is that compensating for? Like,
Compensating
sagging?
for when they, it's like an opposite to a sag,
Cool.
for when they weighted it. Now the issue was, the poor guy on the forklift was zooming around, loading all the things, but of course you had this very trampoline-like floor, because there was nothing holding it down except for the weight that was supposed to be there. So it was the funniest thing I've ever seen. It was like Postman Pat driving along on his forklift. He was bouncing, literally bouncing on these rubber forklifts. He had to go so slow it wasn't funny. And we were getting close to opening day and he was taking forever to load all the shelves up. Because if he put a bit of speed on it, it was like a trampoline. So that was a downside of it, but the upside of it was that the Uni-Ts were trumped by twin T's underneath the building. So I know a lot of you are going to go straight from here after the lecture to Mount Albert Pack and Save and have a look at the Uni-Ts, don't you? The twin T's. Of course you are, yeah. What I should do is put half a mark written on one of them if you can find it.
Oh yeah.
Max is off. Okay, there's an example of stacking the precast and how quickly they can do that to form car parks and what have you. The bars, the reinforcing bars. Now, if we go back to the original photo up the top here, if a bar's deformed, it sort of looks a bit like that. And there's a reason for that, in that if it was just shiny or just a shiny bar, smooth, the concrete wouldn't stick to it. So it would be okay for up and down movement, but if the concrete started doing that, the bar would just slip and just slip away. It wouldn't grip it. So by putting those things on, by making the bar like that, the concrete goes around it and grips the bar, so it's not vulnerable to shear forces. It can take forces in all directions. So if anyone asks you about that, that's the main reason why bars look rather odd when you look at them. I don't know if Ingrid put in some reinforcing. She normally does, but I've got some in my office somewhere. I probably should have brought it in today. but next time you're going past a building site, and crikey, there's quite a few of them, have a wee look at the reinforcing, what it actually looks like. Driveways. With the reinforcing, you have to somehow lift it up and make it so it's not floating, because you can't just kind of pour the concrete and lift the reinforcing up and have it about that much above the ground. They often, if you've ever seen driveways, they put the mesh down like that, and then they have these little things they slide underneath to keep it up off the ground, so that you get concrete underneath it, and that concrete underneath is called the cover. And cover is the most important thing that you're going to do with reinforcing. If you think about it, what's the most vulnerable thing that can happen to reinforcing? It can rust. How's it going to rust? Because there's not enough cover, or because it's near a geothermal site or the salt water. So if you've got salt water or geothermal going on, you've got to have a decent cover. Now that cover's determined by a geotechnical engineer. And by the way, I was just reading the other day, I was talking to a guy that's involved with the registration of engineers from Polytech, and already they're starting to take Polytech qualified geotechnical engineers with 10 years experience. They're allowing them to sign off on quite a lot of stuff to do with geotech, because universities aren't pumping enough of them out. Universities tend to have the very brainy structurals, or the kind of lazy traffic engineers, but they don't have a lot of the geotechnicals coming out of the university. So they've decided that the BNG Tech students with 10 years experience should be able to sign that off. And the other one they're working on at the moment is stormwater and sewage drainage, that sort of thing, with 10 years experience. So the world's changing. In my time, they wouldn't even dream of doing that with a BNG Tech. Now they're talking about certification. By the way, that's only New Zealand. Okay, we're not talking Australia, Canada, England, Saudi Arabia, whatever. It's only New Zealand, but it's a good start. So we need to look very seriously at cover. And where does the cover come from? Well, if you have a look down at the sketch here, you can see that the cover goes to the edge of the bar, not the centre line. A lot of people, when they draw a reinforcing, make the mistake of offsetting for the cover and drawing along the centre line, and that means some of the bar's gone into the cover. So if your cover is 50 and your bar is 16, then you offset 50 plus 16, which is 66, and that's your new centre line for the bar. So 50 plus 8, 58, that's the centre line for the bar. Okay, so when you're drawing it, think about those things. I quite like students to to offset for the cover and leave that line on there so I can check their drawing. Normally in the real world we wouldn't leave that line on, but I like to see that you've understood.
Or Rosa, you mean gap between
The ear or the edge of the concrete and the reinforcing inside. Yeah.
You need that to determine the stone size so that you can
Yeah.
form a.
Now, just as a FYI, it's not always the same cover all the way around. Usually it is, but if you're on geothermal sites, obviously the ground, anything by the ground might be 100 mil cover, and everything by the ear might be 50 mil cover. If you're up against this,
Wastewater as well, because of the rust and the acid, so.
yeah, it just depends. Like obviously up against salt water, that wall, that face is going to be quite a lot more cover than the one that's not facing the salt water. So There's information there on different ways of pouring the concrete and on spacers. We have things called spacers and chairs. Chairs are a funny term. It's not like what I'm sitting on. They sort of look a bit like this. And the reinforcing bars sit there. So the chair kind of keeps them equal distant from each other, and they're usually made of plastic. In my time, when they bound the reinforcing together, they used wire, but of course cable ties are what they, the plastic ones is what they use these days. They're quick, just and just leave them there in the concrete. And there's also something called a spacer that looks kind of a bit like this. It's plastic, and it just every now and then they'll put them that way so that it keeps the bars, the bar doesn't go in and out like that, keeps it equidistant. There's all sorts of fancy little things that Steelies have got now. They're very interesting people, Steelies. I don't know if you've ever seen the little caps that they put on top of the reinforcing. When you're driving along, you see a site with all the reinforcing sticking up, little wee yellow caps sticking on them all. That's compulsory now. Do you know why?
I think for safety.
Truck hazard safety.
I bet you.
I'm telling you.
Yeah, it's a shame it wasn't worth half a mark, but no, it is. It is worth half a mark, unless you've already got one.
Yeah.
Oh,
You can give someone.
that's very generous, but no. Keep answering them. You're doing good for me. Yeah. The Steely that we had on the Clyde Dam, he was eating his lunch and we're eating our lunch, and he goes, "Oh yeah, well the last site I was on at Marsden Point," and I went, "Oh yeah, that's right, I remember that one." He says, "Yeah, a guy fell off the top of the building and went straight through the reinforcing. He lasted about 6 hours. We were all talking to him before he died, and I'm trying to eat my lunch going, I was only 20 years of age. I'm choking down my lunch going, I don't really need to sit beside him again." The next story he told was of a union meeting where the Black Power hired guys to come and beat up anyone that said no when they were voting. So there'd be a vote, will we go on strike? Everyone's, yeah, and a couple of guys at the back went, no! And they ended up on the ground with bits of 4x2 sticking out of their head. So, he was not a very nice guy to have lunch beside. But they had good work stories anyway, better than mine in a consultancy. I mean, those paper cuts really, really do hurt. Okay. Okay, I said I'd get to this just before I finish the notes. That's what I tried to draw here. And I said to you that I'd tell you the secret code for reinforcing when you're drawing it. And that's it here, basically, in a nutshell. So what that means is there's 8 reinforcing bars from that point to that point. They look like that. As you can see, there's a wee bit of cover on each end, right? The cover that you were talking about before. D16, you know from Ingrid that means a 16mm diameter bar. 01 is what we call the mark. If you watch a lot of movies, a mark's something completely different. If you don't watch movies and you're into reinforcing, a mark is just a number that gets more and more and more. So that's 01. You'll notice the next one up here is 02, and so on. Usually we start from the bottom foundation and we work our way up with the marks. So by the time we get to level 25, we might be up to mark 99 or something, right? My example doesn't really do that, unfortunately. I start from the top and number down, so I've kind of broken that rule, but generally speaking, they lay the bars out according to the mark. So if this is the lay down space for the reinforcing, they'll start with 1 here, 02, 03, 04 and that, so when they pick it up to put it on site, they're in order. You know, they do that with building frames as well and all that sort of thing, but that's what they do with the reinforcing. 250 is the spacing. Now I must say that is the engineering designed spacing. When you work out the bars, it might come to 243.6. That's the spacing that they'll put it on site. All right, they don't go 250, 250, 250, and at the end, they've got two bars right beside each other. They spread them evenly all the way. Okay, a bit like when you put those trusses on the roof. Those there's 9 or 10 of them or whatever there are. They're evenly spaced. You don't do one at 1200 all the way, and then you've got like two beside each other at the end. EF is the location. This is a wall, not a concrete slab. On a wall, you have near face, NF, far face, FF, and each face, EF. On a slab, on the ground, you have top and bottom. That's easy to remember. But if the bars go that way and that way, we have each way. But if they go that way and that way and that way and on the other side, that is each face, each way. So it gets a little bit more confusing. The good news is the assignment's a little bit confusing. So that becomes a little bit of a golden mark. But that is an example there for you to start with. And I'm going to give you another example in a minute when we do it. So that's the notes. There's a few abbreviations further down here which you should take note of. Down the bottom here, there's another example of a bar schedule. And further down is the abbreviations that we use in structural drawings. You may end up needing one of those abbreviations or one or two of those when you're doing your drawings. So I'm going to flip now to jumping around a little bit, but I'm going to flip to where are we? No, back to there. Somehow Moodle has disappeared. Oh, I can't see it underneath it. What can we do about that? Talking to myself doesn't help. Ah, there we are. Okay. So, bang. That. So this week is week 9. If you go to week 9, I'll make something available in a second so you can see it, which is week 9 class example 1 and 2. And we're going to go over number 1 in class. So this is a retaining wall. It's a sketch, a typical sketch a structural engineer might do. What you've got to look at this in terms of is it's like a cross. But it goes for 5 meters. So really it kind of looks like this. It's my attempt at a 3D drawing. So that is that. So there's a reinforcing bar that goes down like that on each side. That bar goes all the way along. Okay? Where there is a bar here which goes up, along and down. That bar goes up, along and down, but it goes all the way to the other end. Okay? Where there are little donuts, as I call them, from AutoCAD, those bars start at this end and they go all the way along, okay? So our job is to do a reinforcing schedule with those. And for me to take you through that step by step for 1201, 1602, 1603, 1604, that's it, 4 bars. That's probably going to take an hour. We'll see. So I'll give you a little bit of time just to digest that. Note there is a table here. There is a minimum lap and something called a bend allowance. Please ignore that, that's for drawing it. But there's also the mass per metre, which we sort of talked about before for the weight.
Won't we need the overlap for our quantities?
The overlap will be required. We will be using that in our calculations, yes, very important. As a general rule, it's 32 times the diameter, but in this case, if there's a table, you use the table. All covers 50, so that's easy. Uh-oh. Luckily, you've all got that in front of you anyway.